Hello everyone, and welcome to this webinar, What's New in Scia Engineer 15. My name is Erka Schepers, and I work for almost 3 years as a customer service engineer for Scia. First, I'm going to explain to you how everything works. So, here you can check your sound settings. In this window, you can type your questions, and at the end of the webinar, I will answer them. When there are a lot of questions, I will also send you an email with the answer. And of course, you can also watch the recordings at our website on our YouTube. First of all, I'm going to start with concrete, and I will show you the settings, how you can design a reinforcement, what are the possible checks, and how the output looks like. Then, the open platform, scripts that are taken from Scia design forms, and how you can make tailor-made calculations. Next, there are also a lot of usability improvements, like general plasticity, 3D results, and improvements in table input, and improvements in table results, and much more. And at last, the engineer report, there are also a lot of improvements made, like relative size of pictures, regeneration of reports and batch analysis, predefined sets when sending a picture to the engineer report, and splitting of long PDF files. So first I'm going to start with concrete. In the main menu you will see two options, concrete and concrete 15. Concrete is the option we already know, and concrete 15 is new concrete since Scia Engineer 15. In concrete 15 you can only design and check 1D members, so it's not yet implemented for 2D members. When you will open Concrete 15, you will see that there is a new well-arranged tree. So first you will see there are general settings you can make, so the global settings for the whole structure and the local settings per member. Next you'll see options to design the reinforcement. Then you can input the real bars of reinforcement. And at last you can do the checks. So the global settings are settings for the whole structure, and here you can see the redesigned dialog for this setup. You can choose to show this in a standard way or in an advanced way when you can see a lot more options. You can also set a lot of views according to the chapters from the Eurocode, or you can also make some user-defined views. There is also a possibility to show only the changed values, and then there are also some filters where you can sort and search according to strings. You can also define some local settings, so here you can override settings per member, and they are according to the type of member, so for the beam, column or beam slab. And here you can also see this in a standard or advanced mode. So this is the same as for the old concrete, but now you have also a more transparent arrangement, and there are also a few new possibilities like more exposure classes, direct input of limit crack width, and input for the limit deflection per member. So the reinforcement design for the longitudinal reinforcement can be done for more than one layer if this would be necessary. There's a recalculation of the statically required reinforcement into real bars. For columns, there's now design for arbitrary shape of the cross-section. And for beams, there's also taken into account the bending moment with respect to the z-axis. So the previous solution respected just one moment, that around the y-axis. So now the reinforcement can also display it for each axis. To design the shear reinforcement, biaxial shear and torsion are now supported. For columns, in the past, the design was based only on detail provisions, but now it is able to design the statically required reinforcement with respect to the acting load, so biaxial shear, torsion and their direction. There is a possibility to input angle of shear reinforcement, And there is an automatic calculation of the angle of compressive strut to satisfy the condition of minimal amount of designed reinforcement. After the design has done, you can do some checks. So there is the capacity check based on the resistance calculated from the interaction diagram, and it can generate 3 types of diagrams. Also, now it is possible to run the check for plain concrete. The response check is based on the check of ultimate stresses and strains. In the old solution it was only on strain, and you can also see the presentation parameters for the plane of deformation. The check of shear and torsion is a check of biaxial shear, torsion, and a direction of shear and torsion. The check can also be done for columns. There's an automatic calculation of concrete strut angle. There is also an improved creation of the effective thin-walled cross-section and the improvement of calculation for shear width. There's also a new algorithm for calculation of the shear reinforcement for the check. Then the check of stress limitation is a new check. So in the old solution it only existed for pre-stressed members. It calculates the cracking forces and it calculates stress and strain for cracked and concrete cross sections. The check can also be done for concrete and reinforcement. Then the check of crack width is a check for biaxial bending moments. The check can also be done for columns. There's a direct calculation of crack width and an automatic calculation of the limit crack width according to exposure class, or there's also possibility to input the limit value as user input. Now there are also more exposure classes supported. Next you have the simple check for deflection based on the calculation of stiffness ratio without necessity to calculate code-dependent deflections. The check can be done for a selected member, not for the whole structure. Then at last you have the check for the detail and provisions. It depends on the type of the member, and the check can be done for longitudinal and shear reinforcement. Then the output has also been improved. Now you have the choice between 3 types of output: brief, standard, or detailed. Brief is just a simple table with unity check values or with required area of reinforcement. Standard is only one page with the most important information. And detailed is an overview of input data followed by a detailed calculation report, and it also includes dynamic images displaying cross-sections, including reinforcement layout, stress and strain distributions in different limit states, interaction diagrams, and clear references to the articles in the Eurocode. So now I'm going to show you all these things in Scia Engineer. Here you can see an example of a simple concrete frame, and now I'm going to concrete 15. First I'm going to the concrete settings for the whole structure, and here you can see the view which I showed you already on my PowerPoint presentation. Here above you have several buttons. You have, for example, find, where you can easily find a word what you are looking for. Here you can change the view, so here you can see I will only see the code chapters, or I will see it in a sort of list. Or you can also show only changed item. Now I've changed nothing, so this window is empty. When you have changed something, you can also save the view, or you can save it to a file and open the file in another project. Then you can choose level standard or advanced, so you can see there are more options that are shown. And here you have also a button with default when it go back to your default settings. When you will change something, so for example I change here something, you will see immediately the difference in font, and here in the view show only changed item, this item is also shown. So nothing has changed, so I'm going to close the window, and then I go to the settings per member, the local settings from the member data. Then you have to select a member. As you can see, this beam is immediately recognized as this type. And here you can also switch on the advanced mode when you have more options. Here you can see where you can input the deflections, crack width, and also you can see you have now more classes where you can choose. The next button is the reinforcement design, where you can ask the internal forces. So I'm going to ask, for example, for this beam, the internal forces. And when I open the preview, you can see I have asked here the detailed output. Here you can see a nice detailed output of the internal forces. Then you can also ask for the slenderness. And here you can see, for example, a brief output. Then the reinforcement design, you can see those values here. So those are required in all of the directions of the axes and also the shear reinforcement. Also here you can see a detailed output. After design you can input practical reinforcement, but this is already done. And then you can do some checks. So here you have got the capacity response check. You can see we're now looking at the standard output. So you can see one page with the most important information. Capacity diagram. This diagram you can also see in the output. To check shear plus torsion, the check of stress limitation. Here you can see it also exceeds the unity check. The check of the crack width. The check of deflection. And the check of detailing provisions. So as you can see, you can ask here for a lot of information. Those are just the standard outputs, but you can also ask the detailed outputs. So it's a nice feature of the new concrete where you can see all of the calculations which have been made. So as you can see, a lot of improvements have been made as you compare it with the old concrete. And there are also some advantages which I will show you in my presentation. There are three main advantages that the new concrete has to offer, and that is the general input of cross-section and loads, the speed that is much faster than the old concrete, and the transparency and output thanks to the technology of Scia design forms. Here you can see a small overview of the general input compared with the Scia Engineer 14 and 15 version. As you can see, arbitrary sections are now supported for the design. Also for the check is this the case. Especially for columns, there has been made a lot of improvements, as you can see in this table. Next you can see a table of an overview of speed compared with the old and new concrete. You can also see an image of the example. So for example, for the design, when you do the design for all of the members, it will be 6 times faster than previously. For all of the columns, it will be even 10 times faster, and for all of the beams, 2 times faster. So you can see also here a big improvement has been made for the columns. And also transparency is a major improvement which has been made. So now you can see a detailed output of all the calculations. It is no black box anymore. And this is thanks to the technology of Scia design forms. So then I go to my next topic, Open Platform. Scia design forms helps engineers to centralize and expand their design workflow. The design form scripting environment is very straightforward and designed for engineers who do not have programming experience. These custom engineering calculations can be run as standalone, or they can be integrated in Scia Engineer. So the output we have seen in our calculation, it can be customized as well as numerical as graphical. Dynamic 2D drawings can be generated based on the outcome of design checks. And license codes may be generated to protect the design check or sets of design checks. So there are a few benefits: transparency, as said before, insight into the used calculations, customizable design routines, and simplified sharing and collaboration between specialists. So those checks exist for beams, columns, slabs, walls, and nodes. So the 1D open design has been improved. It already existed, but now you have also the 2D open design and 0D open design, which are plates, shells, connections, and foundations. And there are also some usability improvements been made. When you will install Scia Engineer 15, Scia Design Forms 15 will also be installed. This requires a license, but you can also use it for 30 days as a tryout. You will also see there are 4 examples already integrated into Scia Engineer, which you can use, and you can also customize them. There is also a direct link in Scia Engineer to the builder, which calls Open in Script Editor. There is also a button Run using model data files, and this allows the user to review all variables and values that are being transferred between Scia Engineer and Scia design forms. And you have also the opportunity to switch on the combination keys so you can see also them in the output. I will show you this technology in Scia Engineer, also on the same example we've seen before. So I'm going to close the concrete menu, and then I will go to design forms checks. And here you'll see there are already some examples installed in the installation. So here I go to the reinforcement design rectangle. I open the preview. This is now the brief. I can also pick here the standard preview. Those are all the parameters. So this is a form which is scripted in Scia design forms. When I go to the check manager, you can also see those 4 examples. When I go to the example we already saw, and I go open it in the script editor, you will see that this form is opened in Scia Design Forms. And here you can make changes as user. For example, I'm going to change the title. Changed by Scia Engineer. No? And you can also change some formulas. For example, here formula, I can change here the coefficient. When you have done some changes and you want to see them also in the form, you have to click on refresh and you will also see them here and here. Now, how can you use this form in Scia Engineer? I go to File, Save As. I'm going to save it in my user map so I can open it directly. Save. And then you also have to export a CLC file. And next you can just close Scia Design Forms. And in the check manager you can now say I click on new. You can see directly the file I have saved because I saved it in this folder. Okay. So your own check is now added. When I click on close, you will see also that it is added here with other checks. And here you can change also some parameters, for example standard. When I click on refresh, you see immediately the changes I have made here. So changed by Scia, and also the coefficient which is changed here. So you have made your own calculation and your own check. As you can see, this is a very nice feature which can easily be used by any one of us. Now I will go back to my PowerPoint and I will start with the usability improvements. The first one is composite design, but it will not yet be included in the first release of Scia Engineer 15. But here we'll see a summary of functionalities that will be expected in a few months. A webinar is planned in that period to see it more in detail. As you can see, it is only for buildings and there's an automatic calculation of the effective width. The next one is general plasticity. This is a brand new development related to nonlinear calculations. This nonlinearity lies in the behavior of the material. Scia Engineer 15 implements a new type of material behavior for 2D members. The plastic zone is based on the von Mises yield condition. This calculation can be useful for users dealing with steel pressure vessels and also other analyses that require to take into account the plastic material behavior. Also a small remark. This functionality is included in a separate module ESAS.47. I will show you a small example in Scia Engineer. I'll go to another example, plastic beam. Actually, the beam which you can see here is not a 1D member, but it's made of different 2D members, so keep that in mind. General plasticity, you have to activate it in the functionality, so here you can see its nonlinearity and general plasticity is activated. Then, in libraries, materials, you'll see here a new branch, material behavior for nonlinear analysis, and here you can choose the material behavior. The model is already calculated, so I can take a look at the results. Then I go to 2D members, and I can take a look, for example, at displacement of nodes. I take a look for my nonlinear combination, so it takes the plasticity into account. And when I compare it with the load case, it's the same one, you can see here a big difference. When I will take a look at the stresses, to my von Mises stress, click on refresh, you can see here nice in 2D members the plasticity. When I compare it with my linear load case, can you see also here a big difference. Now I will go back to the PowerPoint. And I go to the next improvement, the design of steel structures. Version 15 of Scia Engineer features new Eurocode stability checks, featuring increased speed and more transparency in the calculations. In addition, version 15 focuses on torsional flexural buckling, lateral torsional buckling, shear buckling with or without stiffeners, and stability under a combination of load effects. Moreover, calculation reports have been improved significantly. Tabulated overviews have been extended with additional clarifications, intermediate calculation steps, warnings and notes, and clear reference to used clauses from design code or other technical publications. The changes pertain to both checks and ambient temperatures and under fire conditions. For the design of steel connections, there is a new bolt dialog and there are more refactored components. There are also new types of steel connections. For the extended end plate with multiple bolt rows outside of beam, the Eurocode exclusively addresses moment-rigid connections with a single bolt row outside the tension flange of a connected beam. However, the SCI publication, Moment-Resisting Joints to Eurocode 3, gives additional rules for the case of multiple bolt rows outside the beam. The design method is based on the plastic yield line theory. For the type haunch on top, brings Scia Engineer 15 the possibility to define a haunch, flanged or from a single plate, at the top of a beam. The user may define a haunch at the top of the steel connection, at the bottom of the connection, or both at the top and bottom of the connection. There has also done some improvements in base plate design. In previous versions, the interaction check for simultaneous action of bending moment and axial force was performed during the design of base connections. After a careful review of the design code Eurocode 318, however, it was established that the effect of normal force on the connection is already taken into account in the calculation of the moment resistance. Therefore, the interaction check was removed from the base plate design. Also, for the design of steel connections, there is planned a webinar within a few months where you can view these types more in detail. The next usability improvement is 3D stress and 3D displacements. This already existed for 1D members, and there has been some improvements for 1D members, like improvement of display of 3D results on 1D members with openings, and display of 3D results for ribs. Now, since Scia Engineer 15, you can also view 3D results for 2D members. The values have been increased by membrane stress and stress components typical for 2D members. All this together provides a unique possibility to see 1D and 2D results together in one view. Engineers can display global deformed structures and obtain clear view of the behavior of the structure. As you can see in the images attached, this is really a nice view of the behavior of elements. I can show you this also in our example of plastic beam. In the results menu, you can take a look at the 3D displacements and 3D stress. For example, I'll take a look at 3D displacements. Here you can choose for which members you want to see the results. So here you can check as well 1D as 2D members. Here you can set also locations, values, system, extremes. And when I click refresh, you can see the 3D results. You can also check the option Deform Structure, and then you can see also the behavior of the beam. I'm gonna change my scale a little bit. And then you can also take a look at the 3D stress. Here you have the same configuration. Refresh. And here I can also check the deformed structure. And here you can also see a nice image how the beam will behave. Then I will go back to my PowerPoint. And I will take a look at the next improvement. The possibility to display results for 2D members calculated via OpenDesign have been extended. Now it is possible to use averaging strips and show results on edges and along selected sections. There is also a new type of solver for eigenvalue problems. It is now possible to select different eigenvalue solver for dynamics and stability. Moreover, a new type of solver for eigenvalue problems have been introduced in version 15. It is called polynomial method and is based on a widely known theory. This method can lead to shorter calculation time in comparison to the Langkos method. The polynomial method is recommended for eigenvalue problems in dynamics. There have also improvements been done for the design of timber members. It is now possible to disable the check for compression perpendicular to the grain when executing a timber check. The environmental class may now also be defined via the member data settings. The table input structure has been reorganized to avoid tabs overcrowding the screen. The new arrangement includes primary tabs, vertical, representing the categories structure, load, libraries, and secondary tabs, horizontal. There have also new secondary tabs have been added, like load cases, generated force, and nonlinear combinations. Selection of multiple rows, or by the property button, can be used to create named selection of members. Selections can be saved. There is also a new layout of the table results toolbar. Multiple tabs allow the user to open and consult multiple result tables at the same time. The button Delete all tabs is added to clear table results. Table result now display color-code extremities in each column of a table. And here also new tabs were added, like the 1D concrete design, the subso C parameters, and the context stresses of 2D members. Also, it's now possible to determine the selection of members for which results are to be shown via the Properties window of the result item. The improvements of table input and table results I will now show you in Scia Engineer. First, I'm going to open the table input. So I'll click with the right mouse button and then choose here table input. And here you can see immediately on the left side structure, load, libraries. So now it's very practical to switch between those entities. When you have chosen, for example, structure, you can choose here for nodes, 2D members, support nodes. So here you can make a choice from which values you want to see. Now it's also possible to select multiple properties at one time. So here I can select 2D members, and you can also see in the model they are also selected. So it's very easy to make some selections by user. Or another possibility is to use the filter. For example, all elements of thickness 11 can I now select with the filter. There is also a new button added here. Here you can send immediately this table to the engineer port, and the same you can also find in the table results. I'm going to close the table input. I'm going to open the table results. See the table results. And you can see this one is empty. So you have to ask for a certain result. Refresh. And then you have to generate the table results. I don't know if you see it very good on my screen, but you will see in each column some values which are blue or red. So the extremes are colored in those two color. From now it's also possible to ask for multiple results. When I refresh, you will see that another tab will be opened here. So you can switch back to those results in the form of a table. When you want to clear the table results, you will see a button here where you can delete all of the tabs you have created. Also, those improvements are very practical in use. Now I'll open back my PowerPoint presentation. Since Scia Engineer 15, it is also possible to use hotkeys for a set of most common comments. Here you can see a list of the comments which now can be used. And at last, we will see some improvements for the engineering report, like for example, relative size of pictures. So when sending or inserting an image to engineering report, be it a live image of the model or an external image, the user may specify the image size. DWG import is extended with color recognition. Inserting of saved reports into other reports. Regeneration of reports in batch analysis. Quick image settings, so when inserting pictures from Scia Engineer to the engineering report, it is possible to read values of the properties from one of 4 predefined sets defined by the user. Splitting of long PDFs, so the user may now select to split a report into multiple files when exporting to PDF. Fonts for formatted text. The font and size of formatted text can now be changed via the property window of the item in the engineering report. Hiding empty tables. A checkbox in the report properties determines whether empty tables should be skipped and thus not displayed and printed with other report items. There are also a lot more improvements, like improved scrolling, so images in report are now only rendered if scrolling does not continue. This speeds up the viewing and handling of long reports. More effective handling of external pictures. In the background, external images are now stored as JPG files, while these were previously stored as BMP files, so the change results in memory savings and in smaller ISA files. Removing corrupt and empty items. The data structure of the engineer report is checked for corrupt and empty items, which are, if needed, removed from the report. And, so you have seen before, the new preview window is now identical to the engineer report window, which offers a higher performance in display of results in tabular form, including adaptable headers, footers, page, format, and styles. Also interesting to know, when you press the F1 hotkey, the keyboard shortcut opens the up-to-date Scia Engineer help. So when you have any questions, you can search there for the answer. So now I will show you some improvements in the engineer report. So I'm going to make a new engineer report. And here you can see already in the properties the button hiding empty tables. Also, when I insert formatted text, you can see immediately in the properties that you can specify the font. In older versions, you had to specify it in the style. When you would print the report, or better, when you would export it to PDF, you have now an option to split it into multiple PDF files, so you can specify the page in one file. Exit. Now I'm going to send a picture to the report, so I click the right mouse button and I just say live picture into engineering report. And in this window, you will see the picture size, so the relative picture size, which you can now choose here, and also some predefined sets. So here you can choose some properties which you want to use for multiple pictures, and then you can just save it into a position and reuse it for another picture. Insert and close. Then, when you would calculate the project, you have now also the option to have the regeneration of the engineering report after your calculation. So when you have long calculation, you start it at the end of the day or the day after, you will see that everything is calculated and also your report is up to date. Here you have also an option to choose which report to generate when you have multiple reports. Note that some of those functionalities need module ESA.06, so for example this regeneration, the module is necessary. So those were a few very nice features of the engineering report. I go back to the PowerPoint. Finally, I want to thank you all for your attention, and I hope you enjoyed the webinar about the exciting new features Scia Engineer 15 has to offer. Now I can respond to your current questions. Also, do not forget to participate in our next webinars. If you would have any further questions, do not hesitate to contact your sales representative or the support department. Thank you.